Hello everyone, welcome to my course Introduction to Market Structures. We have completed the game theory portion. Now we are going to apply that game theory tools to study the market behavior and how the firms decide. Okay? So, first model that we are going to do is Cournot Duopoly. In Cournot Duopoly there are two firms. Okay? And in Cournot competition each firm chooses quantity. Okay. So, they will decide how much amount of output they want to produce or they want to sell in the market. Okay. And now while deciding these outputs, they are going to decide it strategically. What do we mean by strategically? That means when firm 1 decides its output, it will take the output of firm 2 as given, that some amount of output is going to be produced by firm 2. Similarly, when firm 2 decides its output, that is Q2, it will take the output of firm 1 as given, some amount. So, in this way they behave strategically. But in the previous models of markets that we have done in a competitive market, they take the market price as given. So, how other firms are behaving, it does not matter in that model, or in monopoly there is only one firm. So, it does not matter how other firms are, because there does not exist any other firm, but here there are two firms. And so, while deciding output they will take the output of other firm as given. So, this information is known. Okay. Now, again based on this price output, the aggregate, we will get the aggregate output, and that aggregate output is going to determine the market price. Okay. And here we make one more assumption, and that assumption is that each firm produces homogeneous product. It means that whether a consumer buys from a firm 1 or from firm 2, it does not matter, they are going to get the same product or same good. Okay. And first we will assume that the market demand is this. So, it is a downward sloping demand curve. So, if we take output, aggregate output here, price here, then this is something like this, where this is A and this point is A. So, this is our market demand curve. Okay. And this Q is the aggregate output. So, it is sum of output of firm 1, that is Q1, and output of firm 2, that is Q2, that gives us the aggregate output, that is capital output, capital Q. Okay. Now, here once this Q1 and Q2 are decided, Q1 by firm 1 and Q2 by firm 2, then we plug in this, we get this, and from this inverse demand curve we get the market price. So, market price is determined based on the aggregate market demand curve. Okay. So, each firm decides the output it is going to sell, and then that determines the aggregate output, and that aggregate output determines the market price. So, the market price is not decided by the firm. Market price is an outcome of the outputs that is chosen by each firm. Okay. Now, we specify the cost function, because there are firms and to produce output they will require input, and so they have a cost, and we have done this already. So, we assume that the cost function is of this form for firm 1. So, this is C1 Q1 plus A. Q1 is the output. So, this portion is the variable cost, and this is the fixed cost. And same here, this portion is the variable cost, and this is the fixed cost. And we assume that the variable costs are not same for each firm. Why? Because they may have some differences in technology, or they may say different wages, or many reasons. Okay? Or they may be using a different combination. So, that is why. Okay. So, here if we take this cost function of farm 1 in this, then the marginal cost of farm 1 is C1 and marginal cost of farm 2 we will get in this form. So, it is constant. So, we are assuming that there is CRS production function, okay? And this fixed cost may arise from some factor which is fixed, like you can take rent that we pay for the land. So, we are mainly varying machines and labor, but land is suppose fixed, we do not vary. We suppose this land size is sufficiently big and we can keep on expanding our capacity. So, that in that case we can, the rent that we pay, it can be a form of fixed cost. Another fixed cost can be like the license fee that we pay to set up a farm. So, those kind of things will constitute this fixed cost. Now, here we are making, I should have specified, here we are making that farm 1 knows the cost function. Okay, we will do this later, not now. So, we have got this specification of cost of each farm. Okay. Now, let us talk about the game. Now, here what is happening, each farm choose Qi, farm I 1 and 2. So, that is 2 farm 1 and farm 2, and they can choose Q from this range from 0 to infinity, okay, infinity not included. Okay. So, this you can say is the strategy set, okay, of farm 1 and farm 2. And the strategies are to choose Q1 of farm 1 and Q2 of farm 2. They simultaneously choose this and they choose it only once. So, you can think of this as a simultaneous move static game. Okay. So, both these farms are taking the decision to produce output simultaneously at the same point in time or at the same time, and they are choosing it only once. Okay. Right. Now, here we have, so this is a part of complete information. Now, this is a simultaneous move static game. Now, this is also a complete information game. Complete information in the sense that farm 1 knows the payoff function of farm 2. So, this is known to farm 1 and farm 2 also knows this. What are these? I will come to it. Okay. Now, here we have done the normal form game in the game theory portion. There we have assumed like this kind of games, right. So, this is player 1, this is player 2, they are strategy 1, strategy 2, strategy. So, they have 2 strategies or 2 actions, and these are the payoffs we have specified here the space. So, this was kind of normal form or strategic form game that we have done. Here this strategy space or the strategy set is a continuous thing, it lies here. Okay. Instead of this discrete action or discrete strategies, we have now continuous strategies. Okay. This is the difference from the thing that we have done earlier. And the payoffs of each one we have to specify. So, we have specified the strategies or the actions, that strategy set. Now, we have to specify the payoff. So, payoff is the profit. Okay. And for farm 1 it is this. This portion is what? This portion is price, because price is equal to A minus aggregate output. So, this is price, then this price into Q1. So, this is the total revenue, this portion is total revenue. This is the total cost, we have specified the cost. So, total revenue minus total cost is giving me the profit. So, this is the profit of farm 1. Now, this is the price, because market price is going to be the same for each farm. So, this is the price into output of firm 2 Q2 minus this total cost. So, this is the profit of firm 2. So, firm 1 maximizes this, firm 2 maximizes this. Okay. Now, what each firm solves? They solve this problem. So, firm I will choose Qi to maximize this profit, assuming that there is some given level of output of the other firm, and this we represent it in this way. This is the output of other firm. Okay. So, firm 1 maximizes profit pi 1 with respect to Q1, taking Q2 as given, firm 2. So, this portion is bringing in the strategic aspect. Okay. And firm 2 maximizes profit, that is pi 2 with respect to Q2, taking Q1 as given. Okay. And here if you look at this profit function, it is obvious that they are differentiable. Okay. So, now we solve this problem. So, profit of firm 1 is this. So, we maximize this. So, this will give me, if we differentiate with respect to, take the partial with respect to Q1, this will be this. Now, simply first order condition of maximization, this gives me this, and this we called as reaction function of firm 1, or we can write this as it is a function of Q2 in this way. So, it means whatever, if firm 1 takes some level of output of firm 2 as given, then what is the optimal output it should produce? It is given by this function. So, that is why it is called the reaction function. What it is? That if firm 1 believes that firm 2 is going to produce Q2 amount, then what is the optimal for firm 1? It is given by this firm, this function. So, this is the reaction function. And here if you take the second derivative of this, you get the second order condition of this, and it is minus 2, which is always negative. So, that is why this A is always, so this is always going to be the, is going to maximize the profit. Okay? Second order condition is negative at this level. So, we have got the reaction function of firm 1. If you look at this function carefully, what do we get? So, this is right. So, this is what? This portion is total revenue. So, this taking the is the marginal revenue. This is the total cost. So, this is marginal cost. So, at the optimal point or at profit maximizing output, we get marginal revenue should be equal to marginal cost, because this is equal to 0 at the optimal point, right, and this condition is same as what we get in the monopoly thing. So, in the monopoly also the optimal output is decided where the marginal revenue is marginal cost. So, this optimization is similar to what we have done in the monopoly. Only difference is here is that we have considered some given level of output of farm 2, okay, this portion. Similarly, the profit of farm 2 is this. This is again first order condition implies, so this implies so this is the reaction function of farm 2, which we write as function of output of farm 1. So, if farm 2 believes that the output of farm 1 is this much, then what is the optimal output it should produce? It should produce based on this function and this much, okay, it is given by this. So, now we know the reaction function. Okay. So, we know that if farm 1 believes output of farm 2 is this much, then how much it is going to produce, and similarly if farm 2 believes that our farm 1 is going to produce this much, then how much output it should produce. So, based on these two reaction function, so that is this, we get the this one. Yes. Now, we solve these two equation. These two are linear equation and we can solve them. This is the output of farm 1, and for output of farm 2, you can write simply this. So, these 2 points is going to solve this. So, that means when farm 1 believes that the output of farm 2 is this, then its optimal output is this, and simultaneously farm 2 believes the output of farm 1 is this much, so it produces this. So, that is why the Nash equilibrium here, the Nash equilibrium, or you can say pure strategy, Nash equilibrium outputs are Q1 is equal to this, and when we plug these outputs in the profit function, we get the Nash equilibrium profit. So, while after solving this, we get it so this is the profit of firm 1, and similarly profit of firm 2. If you solved it, is this. So, this is the Nash equilibrium outcome. Okay. Now, here we have got this outcome. Now, actually let us solve this through diagram to understand it better way. So, we will use the reaction function. So, reaction function of firm 1 is this. So, when output is 0, this is 0, then Q2 is here, it is this, right. And when Q2 is 0, Q1 is here, this is, and this is a straight line, it is this. So, this is the reaction function of firm 1, okay, or you take it like this. Okay. Now, here reaction function of firm 2 is this. So, if Q1 is 0, it is Q1 is 0, it is A minus C2 is equal to divided by 2 is equal to Q2. So, suppose it is this, and when Q2 is equal to 0, it is A minus C2 is equal to Q1. Suppose it is here, A minus C2. Okay, and this is the reaction function of firm 2. This is the point of intersection. That means, at this point these two equation is the, this is the solution of these two equations. So, this Q1 is A plus C2 minus C1 divided by 3. This Q2 is equal to A plus C1 minus 2 C2 divided by 3. We have found that. Now, here this is the point where two reaction functions are intersecting, and that point gives us the pure strategy Nash equilibrium. Why? Because see, suppose firm 1, this is the reaction function of firm 1, If farm 1 thinks that the output of farm 2 is this, then it is going to produce, suppose farm 1 thinks the output of farm 2 is this, then the optimal output it should produce is this much from the reaction function, right. But when farm 2 thinks that the output of farm 1 is this much, it should produce this much amount. It should produce this much amount, not this. So, there is a mismatch in the belief. So, that is why it is not a Nash equilibrium. Then what will happen if it thinks in this way, then farm 2, since farm 2 has thought that output is this, so it has produced this much. Now, farm 1, it will come to know that output of farm 2 is this much. So, it will assume that output is this, so it will produce this, so its output is going to be this much. When farm 2 thinks that the output of farm 1 is this, it is going to produce this much. So, you will see that they will slowly come to this point, and this is the point, Nash equilibrium point. Now, here in this situation, we get this solution, this for under what assumption? So, we have not yet specified that assumption, but we have implicitly assumed it. So, that assumptions are that this A minus C1 should be greater than A minus C2 divided by 2. So, this should be greater. So, then we will get, so this implies that A minus A should be positive. Or, so if we have only this situation, so that means this is going to be lower than this. Then, since they are downward sloping from this A equation, we know these two equations. So, that is why what we are going to get? We are going to get that actually it will be there, since we are assuming it is like this and it is like this point. So, it will be there. So, we have a point of intersection, right. But can we have a situation like this? This is A is, this is greater than A minus, right. Like this, can we have a situation like this? This is, this is so, this is, so there is no intersection point, so there is no solution. Can we have this situation? Because from here we have got this, right. If we have this situation, then only we will get, right. We have assumed this, but then we can have this situation. If we have this situation, that means what? From here, what do we get? A minus C1 divided by 2 is actually greater than A minus 2. Okay. So, this we can have, this will be, this is assuming what? So, this will imply what? This will give us this. Now, we have assumed this, so we have got this. Now, we may have this situation. So, if we have this situation, if this is true, then it does not imply that this is not true. This can be true, okay, if C2 is sufficiently small, right. If C2 is sufficiently big, okay, or C1 is sufficiently small, okay, we can have this situation, and in that case we will have no intersection point in the positive orthant. So, we will require this. So, this may not happen. So, we require this condition also, that 1 minus C2 is greater than. So, this implies A minus 2 C2 plus C1 is positive. So, for a solution to exist, in this case we require these two conditions. These two conditions are. Then only we will have a pure strategy Nash equilibrium, and the situation will be such that it will be positive. That is, these two conditions will ensure that Q1 is positive and Q2 is positive. If we do not have this situation, then we will not have a pure strategy Nash equilibrium where output of each firm is positive. And this is also this outcome, that is Q1 is equal to and Q2 is, this is also called Cournot-Nash outcome. Cournot-Nash outcome. Why? Because when Cournot proposed this model, at that time game theory was not developed. So, Nash later on developed this non-cooperative game theory, and then combining these two approach, we get this as the outcome. Okay. Now, here while we are drawing this, you see at this point only beliefs are also matched. That is, when I assume that the firm 2 is going to behave in this way, and in response I choose this. Similarly, firm 2 thinks my output is this and then chooses this as output. So, if that is not there, then we will not be in a Nash equilibrium. So, it is something like this, that when we are, suppose consider this game, how we have found the Nash equilibrium. Okay. How? So, if player 1 thinks, if player 1 is choosing this, okay, player 1 is choosing this, then what? So, player 2 thinks that suppose player 1 is playing this, what is going to be my best here? My best is to choose this. Okay. So, here you can say when firm 2 is choosing its output, it should think that what is the firm 1 is going to produce, okay, and then based on that it is going to choose the optimal output. So, if firm 2 thinks that firm 1 is going to choose this, its best response is this, okay, and when firm 2 is choosing this, best response is to choose this. So, that is why they are deviating. It is firm 1, firm 2 assume that firm 1 is producing this, and then it has decided to produce this, choose this strategy. Then when firm 1 is assuming that this is the strategy of firm 2, then it is not choosing this, but it is this. So, that is why this is not an Nash equilibrium. So, here farm 1 is choosing S2. When farm 1 is choosing S2, this farm 2 is going to choose S2. So, that is why this is a Nash equilibrium, pure strategy Nash equilibrium. Same thing is happening here. If this is the reaction function of farm 1 and this is the reaction function of farm 2, at this point what is happening? Farm 1 believes that farm 2 is going to produce this much. So, it produces this, okay, and farm 2 assumes that farm 1 is going to produce this, and so it produces this. So, they are matched. So, that is why this is a Nash equilibrium. But consider any other point like this here. Suppose farm 1 thinks the output of farm 2 is this much, then it is going to produce this much level of output. If it produces this much output, so it is given by this amount, then farm 2, its reaction function is this, it should produce this output, this much, not this. So, that is why they are not matched. So, only the solution of these reaction functions is going to give you the Nash equilibrium, because here it is deviating, right. From this output, farm 1 thought that output of farm 2 is this much, and then based on that it produced this. But farm 2, when it assumes that the farm 1 is going to produce this much, it is not producing this, but it is producing less than that. So, it is deviating. So, that is why this is not a Nash equilibrium, only the point, intersection point is the Nash equilibrium. Okay. So, this is the solution of Cournot outcome in a two farm case. Okay. Now, we will show that this Cournot outcome is similar to something like we have done, that the prisoner's dilemma kind of thing. So, to do that, what we will assume for our simplicity, that suppose C1 is equal to C2, that is marginal cost are same. So, this Nash equilibrium output, which was this, it becomes right. And if you plug in these outputs in the profit, profit is going to be and this is going to be this, right. Simply in this function, you do the substitution, you will get this out, this thing. So, the Nash equilibrium profit of farm 1 is this, and it is this for farm 2. Now, instead of this playing strategically, choosing output simultaneously without any coordination or without any discussion among them, now suppose the farm 1 and farm 2 make a collusion. Collusion in the sense that what they do, now from here this assumption makes that these two farms are similar, right. Since these two farms are similar, so they decide that let us produce monopoly output and share the profit equally. What does this mean? So, we know the monopoly thing. So, these farms are similar. So, it does not matter whether farm 1 produces or farm 2 produces. Okay? So, market demand, inverse market demand is this Now, assume that they are going to act as a monopoly. So, only one firm produces. So, it is, you can think, one firm is going to sell only. So, this is the profit. Now, we this is the monopoly output. Now, what it can do, since the firms are similar, so this they can share. They said that you produce half of this and I produce half of this. So, this is suppose okay. They are seeing this, and you can think it is this which is equal to Q1 plus Q2. Now, if this is the case, then what is the profit of these firms? Profit of these firms are profit of firm 1 we know this. We know this. It is this, and if we follow the same method, going to be this. Is this. Now, the question is whether they are going to play this Cournot kind of game or they are going to share the market equally. So, the question is here that whether to share the market equally by producing monopoly output. So, this is one, you can think as this is one strategy, or do not bother, simultaneously choose output and play Cournot Nash outcome. Okay, suppose this is. Now, here in this situation, what are the profits? In this situation, profits are this. So, when they share this, so the profit is this, and in this case the profit is, what is the profit? The profit is this much. Okay. Now, suppose firm 1, whether this is going to be implemented automatically. Suppose farm 1 produces monopoly half of this. Then farm 2, how much it should produce? If we use the Nash optimization, so we get a reaction function of like this. So, this is going to be output of farm 2 is this, and not this, right, because this is the half of monopoly A. Suppose farm 1 produces this, then from the reaction function of farm 2 we get farm 2's best response is this. It is optimal, and we have got this from optimizing the output of farm 2 given a output of farm 1. Okay. So, if we take this combination, so then the profit of farm 2 is what? This is okay. So, the reaction function it will have a 2 here, right. So, this will be 3 by 8, this will be 3 by 8 like this. So, this is going to be, so it is again 8 A minus C, 5 A minus C, so profit of farm 2 is going to be this, right. Similarly, if we do the same thing, so we get the profit of farm 1, what it is going to be? It is going to be 3 it is going to be this one, when farm 1 produces, farm 2 produces this half of monopoly A. Now, what you are doing? So, farm 2, suppose farm 1 is producing this much amount of output. So, farm 1 suppose produce this much amount of output. Okay. Then, if it produces this much, farm 2 produces this much, its profit is going to be this much, right. But instead, if it produces this much based on the reaction function, its profit is going to be this much. So, now let us compare the profit here. This, and you will see that this is always less than so, this is going to be So, for farm 2 it is optimal to deviate, instead of producing half of monopoly it should produce more output and this. So, that is why what is happening, farm 2 is deviating, and similarly farm 1, if we compare this profit and this, we get that it is also optimal for farm 1 to deviate if farm 2 produces half of the monopoly output. So, that is why what do we get? They are never going to decide that let us produce half of the monopoly profit. Although, if you look at this profit is greater than this profit. If you simply compare this and this, you will see that this is greater than this. This is greater than this, right, because this is divided by 8 and this is going to be divided by 9. So, even though the Cournot outcome is suboptimal compared to the monopoly, why it is optimal? Because if they decide that let us produce half of the monopoly, then the profit can be at a higher level. But what happened? They cannot decide on that. They cannot come to a conclusion, because if farm 1 decided that let us produce half of the monopoly profit, farm 2 based on its reaction function is going to produce this much level of output and its profit is going to be this much, which is higher than the half of the monopoly profit. Similarly, if farm 2 produces half of the monopoly output, then farm 1 is not going to choose half of monopoly, instead it is going to produce this much amount of output, and so the profit is going to be this much, which is greater than the half of the monopoly profit. So, that is why they cannot come to a outcome which is better than a Cournot outcome, because Cournot outcome is going to give this much profit to each, but they end up having this much profit, but they could have got better profit. This is half of the monopoly profit. So, we will stop at this today. We have done the Cournot Duopoly thing, and we have also shown that the Cournot outcome is actually similar to the prisoner's dilemma. That is, there is another outcome which is better than these two outcomes, but still, since the firms behave in a non-cooperative way, in the sense that they behave what is best for them given the output of other firm, and there is no possibility of any negotiations between them. So, that is why we get the outcome as same as the prisoner's dilemma outcome. Okay? And in the next class, we will extend this model to n firm. Okay? Thank you very much.